Hi, this is Charlie. Welcome to our next lecture. This should be our last lecture before the final, and it's on networking systems. So I hope you enjoy this lecture. I know I will because I have all the content, all the different content that we've covered this semester. I think networking is my favorite. So let me share my screen and we can get started. Well, cybersecurity is my favorite, but for this course, networking, right? Let's see here. Let me minimize this. Okay. So we're on module 7, networking and the internet. I think where you're going to find a lot of this material review from the previous lectures and work that you've done, and also from your knowledge, just your knowledge of using computers, right? So again, there'll be a quiz, our last quiz, yay, right? But then the final, there's a test, and there's an assignment and a discussion on in networking. So here's a couple of nice YouTube links. I do recommend you uh, going to them and watching them, and also chapter 4 in the book is good to read, okay? So let's get to the lecture. Okay, chapter 4. Networking and the internet, right? So we're going to cover some networking fundamentals, the internet, the World Wide Web, stuff that we're used to, right? Internet protocols, just how we communicate across the internet, right? Simple client server, and then security. And security be very brief. So network fundamentals. Uh, so networking software, what it does, it allows you to exchange information, right, and share resources, content, software, data storage facilities. So it allows you to communicate, it allows us to communicate, right, with other computers. Network software has evolved into a network-wide operating system, right? Uh, I view the network as one big computer, right? That's a philosophical view you have of computing. I don't view the network as a bunch of small devices or computers on the network. I view them all as one. Okay, scope. There's a personal area network that's for short range, right? There's a local area network for a building and a campus, metropolitan area for the community, and wider area for greater distances. There's ownership, closed versus open, right? So it's just very basic stuff that I think we should be very well aware of. Topology, there's bus, different kind of the Ethernet. That's what I'm used to, Ethernet or wireless, right? Wireless networks with a central access point, that's star, right? So here's an example of a bus, and here's the Ethernet, and uh, they're able to communicate, like where they communicate each other, and that's through a network card, right? So the network card has a MAC address, and it recognizes the packet where it should be, who should read the packet, right? Who gets the packet. Two pop-in network popular topologies. Two. Here's a switch, uh, and here are a star topology, and here it is with the computers linked to the switch, right? Protocols. Rules by which activities are conducted on a network. So it's very easy if you think of a protocol, it's a way we communicate. We have protocols. Human beings, we communicate with protocols. Maybe we speak English or you speak some other language. That's a protocol. A handshake is a protocol and so forth. So you get the idea. So example, coordinate the transmission of messages between computers, right? You need to avoid all machines transmitting at the same time. So we can't have them all transmitting at the same time, right? So the collision allows vendors to build products that are compatible with products from other vendors. Now, before I go any further, I must tell you that, again, this is a very high level course. Many universities, and I don't know about the University of Arizona, but during my travels of all these years of taking courses and lecturing, Many universities have operating system one course, I mean, networking one, networking two. They may even have one just specialized on networking protocol. So this course cannot do this subject any justice like most of the other lectures. It's just at a very high level to give you an introduction to computing, okay? So, and of course, there's Internet of Things I think we'll cover in this lecture. Uh, these little devices. That's actually was my PhD dissertation was about the Mirai botnet of how the Internet of Things uh, were commanded by Mirai to execute denial of service attacks. Okay, protocols for transmitting messages. CSMA, collision detection. It's using Ethernet. Both machines stop and wait for an independent random time, right? CSMA, collision avoidance. Used in Wi-Fi, where not all machines can hear each other. Give advantage to the matching that has already been waiting, right? So just know there's what you have to know is really what I get at this is that you gotta be aware of collisions. Okay, here's an example. Here's a figure of communication over a bus network. Okay, and here are the arrows showing communication flow. Like for example, this computer in the middle sent something, and when it sends it and it goes on this bus, the message will go to the left and the right. Okay, and so and if you notice, every computer on this bus receives it can receive the message. Uh, but what happens on the bus is that part of the inside and capsulated inside the message that's being transferred is the MAC address, okay? And so actually only the computer with the MAC address will process that information. But as you can see, that's why it's dangerous. You have to be very careful from a cybersecurity perspective because if you're on a bus, you could be listening to all the traffic on that bus, even if it's not intended for you. The hidden terminal problem. Okay. So here's range B. Here's a cell phone. Range C. Here's a cell phone. Range A, the cell phone, right? So none of the ends can hear each other, although each can communicate with the access point, right? Here's the building. There's the access point, but they can't communicate with one another. Combining networks. So this is really some network components that are needed. There's a repeater, passes all messages across two buses, right? So you need a repeater. And the reason why you need a repeater because the bus can only be so long before the messages they don't become strong enough. So there's remember it's going through an Ethernet, right? It's an actual wires. There's a certain length at which the wire can be can there's a certain standard of the length of the wire, and then you need a repeater because the signal weakens from the wire. A bridge passes only messages that are destined for computers on the other bus, which is nice, right? So there's a way that you could uh, sort of per, do more, provide some security there in the sense that you're only going to pass messages that are destined for on the other bus, and that can also help you, of course, with collisions and traffic and so forth. If you use a bridge, switch acts like a bridge, but with two connections to multiple buses, right? With connections to multiple, so a switch is very much like a bridge, but it's multiple buses, right? That's only the bridge is only to two. These are multiple. A router. So we all think of the internet and Cisco routers and stuff like that, right? So connects two incompatible networks, resulting in a network of networks called the internet, right? So, okay, the information gets routed. Building a large bus network for small or from smaller ones. So here's an example. There's one, I'm going to call it subnet. There's a bridge to another network, okay? So there's the bridge. And now here's a switch. If you notice there's only two buses, right? Connects two buses. Here's the switch that we were talking about. There's three buses. So it acts like a bridge, but with three. Routers connecting two Wi-Fi networks and an Ethernet network to form an internet. How interesting, right? So here's a wireless. So out to the left, here's a Wi-Fi network, right? So it's using access point and communicate. Computers are communicating with each other. But if it needed to communicate, if someone in here needed a computer to communicate with somebody's Ethernet network, which could be totally different, right? It's not so different kind of, it's a different kind of network. So a router, it would go through a series of routers, or then maybe this router at the top and then this router to get to uh, this computer here. Well, it has to the computer, but okay, we'll leave it that way as an explanation. And the same thing here. Here's another one, right? So let's say if this Wi-Fi, someone, a member in this Wi-Fi network wanted to communicate with someone in this other Wi-Fi network, it would go through a series of routers and then hit the access point, and then the access point to the to the node. And here I think the router would maybe be a bridge or uh, it would have to be something here, just not. It had to be an internal router to the. What am I saying here? It really would go to the. What we calling this 1 second? It really would be to the bus, right? The information would flow to the bus, would go across the bus, and then it would recognize the MAC address of, say, the computer, and then the computer would process that information, right? So it doesn't go directly to this. Let's say there's a computer. It has to be a networking device, an internal router that then would route it maybe to uh, this bus, okay, this Ethernet network. Methods of process communication, client server, many clients, one server, right? Executing continuously, right? So clients make requests of other processes. Server satisfies requests made by clients. Maybe it's a web server. So you have a bunch of folks trying to retrieve information from it, right? Those would be the clients. Maybe be a web browser. Peer-to-peer, two process communicating is equals. Process execute on a temporary basis. That's a peer-to-peer network. Client server, here we're going to compare the client server model to the peer-to-peer model. So here's a server in the middle, and here are different clients. This could be an SAP ERP system, and folks using SAP and querying the SAP database, for example. Server must be prepared it has to be prepared to serve multiple clients at any time, right? But here in here's B. Here's a peer-to-peer communication. So the computers directly communicate with each other. Distributed systems. Okay, system units that execute as processes on different computers, right? So uh, we have to do this because of we need lots more computing power for our applications today and what we're trying to do. So usually requires more than one computer, right? And the reason why this is important because it's like it's kind of like module. If you think back in the day with a mainframe computer, if it wasn't powerful enough, you'd have to shut the mainframe down. You'd have to buy expensive proprietary stuff for it, get it put in, then bring it back up. Now today with distributed systems, it's really now think of a cloud, for example. You can multiple virtual machines can be can be clustered together, right? And I think okay, they have cloud computing here at the end. I wasn't even reading it. But if you can think of that way, and it's much more inexpensive, it's more flexible, and so that's where we're at. We have distributed systems. System units that execute as processes on different computers. There's cluster computing, right? Independent computers work closely together instead of a single, much larger machine, right? Because it's cheaper and you can adjust how much you add to the cluster. Grid computing, millions of home PCs work on a complex problem. I haven't heard much about grid computing lately. Uh, Cloud computing, of course, that's the latest craze. Provide services, hides the details, right? The internet. We all know the internet. We use it all the time. The internet is an internet that spans the world, right? So the original goal was to link a variety of networks to a connected system unaffected by local disasters. Yes. Today, it's a commercial undertaking that links a worldwide combination of PANs, LANs, MAMs, and WANs involving millions and millions of computers. Here's in our architecture. There's the ISP, there's tier one, that's ISP, Internet Service Providers, right? So there's the tier one, they're the big guys, they're internet backbone. Then there's tier two, okay? Access or tier three, ISP provides connectivity to the internet, hotspots, wireless cell phones, cellular, cable, satellite systems. So I'm accessing tier three, right? Uh, so here's an example of tier one ISPs that could maybe that's AT&T. Um, let's see something here. So these are the big players, right? So AT&T, Verizon, Lumen Technologies, Cogent, GTT, in Asia. So Asia's a little different. China, because China Telecom, China Unicom, Singtel. Europe has someone different, Deutsche Telekom. So it depends on where you're located, who the tier one is. Okay. What makes tier one can reach the entire net without paying transit fees. Only uses settlement-free peering. Okay. Okay, so you can research the rest of that yourself on that's the great thing about ChatGPT. If you're wondering about some of this type of stuff, you can uh go to ChatGPT and learn from it, which I totally recommend you to do. Okay, here's tier two, here's access APs, and there's what would be tier two ISPs, right? Let's see. They're below, right? United States, Comcast, Spectrum, Cox, and so forth. Europe, Vodafone, Swisscom, and so forth, Asia. So anyway, to get an idea where you're located, you could research, well, here is certain tier two. Okay, here's a comparison. This is nice. Pay transit fees, no, yes. Peering, only settlement free, mix of paid. So you get the idea. So there are different, it's tiered. It's multi-tiered, right? Internet addressing. IP address, pattern of 32 or 128 bits often represented in decimal notation. So there's IP version 4, IP version 6. IP version 6 is the 128 bits. No, it isn't. Let's see. Let's see if I said that right. 32 bits. There's an example. We're all used to this, right? A different. Okay. So we're used to that kind of dot notation. Now IP version 6. It's 128 bits, right? And it has this kind of notation, right? So of course it allows for a lot more. That's why they developed IP version 6 because they were running out of IP version 4 addresses, okay? So, and you can read up on that, okay? Okay, and mnemonic address is the mu.edu. Top level domains, I think we're used to them, org, gov, so forth. Domain name system, name servers, DNS lookups, right? So DNS that translates the URL into the actual IP address, right? I can. It allocates blocks of IP addresses to ISPs, who then assign those addresses within their regions, right? So oversees the domains, registration names, early internet applications, network news transfer protocol, file FTP, which by the way is don't use FTP, SFTP. Use a secure version of it. Again, Telnet and a secure shell. Okay, secure shell SSH. That's much more than Telnet. Hypertext HTTP. We're used to HTTPS. I would never use HTT, just HTTP, right? Because it's not secure. Electronic mail. The main server collects incoming mail and transfers outgoing mail, right? So there's electronic mail. Mail servers delivers incoming mail to clients via, so there's two protocols, POP3 or IMAP. Simple mail transfer protocol. Here's an example. So as you can see, here we are sending mail. Hello, mail, share.gov, mail from, so it's telling you a sender, okay. It received it, okay. There's the data, there's the subject. There you go, it's Raylick, okay. More recent applications. Okay, so we have the voice over IP. That's really nice because they're trying to save, why they came up with that, I think, is try to save money in phone calls, long distance phone calls, because they could do it over IP. Internet multimedia streaming. There's Ncast, multicast, on-demand streaming, content delivery networks. They're kind of big, right? So they're geographically located so that when you're accessing some sort of information, maybe you access it as close as you can to where you're geographically located. This way you don't have as far to travel. Of course, routers and stuff like that, the internet. Uh, what did I want to do? Oh, voice over IP. Let's see if I'm right at that. I have never used voice over IP. Well, I may have used it and didn't even realize it in the office. Yes, especially compared to traditional phone lines. I think that's the one idea. It's 10 to $40 per month. Okay. Use the internet instead of phone lines. Well, I know that I use my cellular phone, so okay, so you could if you're interested in that. I'm not too interested in it, to be honest with you. Okay. The World Wide Web, hypertext. Okay, it combines internet technology with the concept of linked documents, embeds hyperlinks. So I think we all noticed we had assignments on this, right? Building websites, and we went over this. Browser presents material to the user, right? You see it through the user. Web servers provide access to the documents. Documents are identified by URLs and transferred using HTTP through HTTPS. I hope. A typical URL. We know this. We had questions like this on our test. Here's the mnemonic name, the eagle.mu.edu. Here's the protocol, HTTP. This is a bad example, okay? I would never go in my browser to HTTP. It had to be HTTPS, the secure version of it, okay? I would never use HTTP. And discovery path, here's the path authors, Shakespeare. Here's the, and the document Julius Caesar HTML. This is nothing new to us. Hypertext markup language, HTML encoded as a text file, contains tags. We went over this. Links to other documents. We use the tool. We use the Google Documents to build our web pages. I did that because I thought it was important to use a tool because that's what you'll be doing out in the real world. You won't be just writing it from scratch and putting it in and no, you won't do that. You'll be writing it with a tool, probably drag and drop tool, or maybe just use HTML, LLM chat GPT to say, here, write me this and put this in there and put that, right? Vibe coding, it's called. So you may even use that. Here's a simple web page. Here's the HTML header. Here's a header, the title, demonstration page, the header. Here's the body, my web page. Click here for another page, and there's the body. Or show an example, HTML. There it is. Okay? An enhanced web page. And here's a reference. So a reference to Clary.com demo And so let's see what this looks like. So here for another page, and you click on here and you go to the other page. XML, extendable markup, is a language for construction markup language similar. It's similar to HTML, XML. A descendant of the standard generalized markup language, opens door to World Wide Web semantic web. Using XML to encode music. Here's an example. Staff clef equals treble, C minor, time 2/4, measure, result. I'm not too big into XML. I don't really use it. Okay, the first two bars of Beethoven's Fifth Symphony. So that's an example. Okay. Client side versus server side. Client side activities. That's when you think of client side, you think of the browser, right? So that would be the language like JavaScript, Java applets, and Macromedia Flash. So the processing done in the client. Now server side, CGI. So servlets, Java server pages, PHP. These languages do the processing that has to be done on the server side. Okay. Internet protocols. Control how messages are transferred over the internet. The software must reside on every computer in the internet must reside, accomplished by a multi-level hierarchy, okay? So package shipping example. Here's the origin. So we'll follow this here. So uh are you prepare the package for shipping. You place package and container for the airline, the shipping company, places container in the airline. Here's arrow transfer. So that it gets transferred from one airline, the package to another. So you're saying, and then another airline, could have been a bus, could have been a tractor trailer, right? And then it goes to the shipping company. The shipping company receives it and then delivers it to your friend, right? Maybe one day it'll be delivered by drones. Who knows? Drones will play a mix into this type of thing. I did see a picture of I don't know if this was a hoax or not, of Amazon using drones. And it's kind of scary. I don't know. I don't know if let me know if anyone else has seen that. Have you seen that stuff on the internet about Amazon trying to use drones and testing them out? Okay, so internet software layers. Okay, so this is simple version. There's the application. So your application you're using on your computer. Okay, so whatever it could be email. You're typing up an email. Okay, so that's and you use an email client. That's the application. Transport chops the messages into packages. So we have to, there's a certain size, the transport layer that'll chop it up, the messages, because it just doesn't just magically just go across. It chops it up into transport layer. The network, the network handles the routing through the internet, right? So that as we talked previously in the lecture, the networking part with the routers, the bridges and so forth, right? And the repeaters, right? And then the link handles the link layer handles the actual transmission of the packets, right? Here we are. Here's a picture of it, the application, the transport. So if you're sending something, you're doing something in an application and it's going to communicate to the internet. You're going to hit the transport layer, you're going to chop it up, then there's the network layer, and then the link layer, right? And then so on the other end, when you're going to receive, let's say you're going to receive from your friend an email or something like that, it's going to go through the link layer, the network layer, the transport layer, and then into your application, right? Could even be a browser. Could be a browser, doesn't have the email. Okay, here we are following a message through. Okay, so application. Here we'll start from on the left side here. So the application prepares message and provides destination address, right? Your address. Chops the message into packets, a transport layer. And then we go to network, assigns intermediate address to each package, right? So IP address, link, transfers the package. It transfers the package. Okay. And so here we hit the link, We go up to the network. What is this box at? Each intermediate stop, the network layer determines the direction in which the packet should be forwarded. So these two in the middle uh, are just examples of that it shouldn't go any past the network layer because the application is not on this network, right? So that's just shown. So you go to the link, network, it says, no, don't have the IP address is not on this network. Let me go next one. The IP address is not on this network. Oh, here we are. The link layer of this network receives the link, and then it gets the IP address. It's okay, yeah, IP address is part of this. That's like the router. Uh, Different layers it works at. We have a very simple view here. And then transfer collects the packets. Transport's going to collect all the packets. And then the application could be a browser, email, client, whatever. And then you get the data. The final destination gets the data. Okay, TCP/IP protocol suite. Transport layer. That's what transmission control protocol, internet protocol. Okay, transport layer. It's a transmission control protocol, and is also called a user datagram protocol, UDP, for the transport layer. Now, UDP is insecure. TCP has a lot of control mechanisms. That's why it's called transmission control protocol, like sequencing number, error codes, and so forth, to make sure that there's nothing happen bad when you're sending the data or reading the data. Okay, but UDP does not have that. Network layer. So we're talking about the IP, the Internet Protocol, and we talked about either IP version 4, IP version 6. Choosing between TCP and UDP. Now there is one advantage of UDP that if you didn't care, so let's say you're just sending data somewhere, you want to store it somewhere. Maybe you have to do it quickly and you don't care. Well, you don't care if it all got sent properly. Then you could use UDP because it's quicker. It doesn't have all that control mechanism in place. That's when you would use it. And so here's the application layer. TCP more reliable and less efficient, more effective but less reliable. Okay. A simple client server program. Socket, it's an abstraction for processes at the application layer to connect to the network via the transport layer. Needs to know you need the source address name, right? You need to know where uh, the client, the address. You need a port number, right? It communicates on ports, just like ships that come into ports. That's why we have ports on our computer, so we have multiple services running, and it can understand the data that's coming in. It's going to use the right protocol because it's using the right port. Destination address and destination port number. Oh, I'm glad they gave an example of a script in Python for this because I was about to show you an example in C. So create a TCP socket. So there's the socket. Uh, so it creates a socket streaming. Okay. Connect to the server listening on localhost 1313. So you have to be careful, right? You don't want to use a port that's already in use for some other reason. Got to be careful of that. Server address localhost, connect to uh, the server address. It connects. Now it's going to send a message to infinity. Buzz Lightyear, to infinity and beyond. Okay. Client sending. So there's how you would do that. Receive reply from the server. So then it receives a reply from the server. You have to receive. Client received. Okay, and close. So I don't think we're going to ask you to write this code. This is just an example. Server script in Python. So create a TCP socket, again, stream, bind the socket to the port, listen for incoming connections, wait for a client to connect. There's the sock that accept, connection from client, and then receive 14. That's it, receive 14. Okay, 14 bytes maybe. It's the length that it receives. Uh, and reply and beyond. Okay, so it's funny. So this sent uh, to infinity and beyond. Okay, server replies and beyond and close. Okay, So I wanted to show you this. So here I asked it to sell me a simple sockets program and give me the comments of the functions as well as the parameters, okay? This is a great tool to learn the LLM, right? So they're very good at code. So here's Python. Okay, so here you go. Here, this describes the socket. AF, that means IP version 4, and that means TCP, sock string, TCP. Okay? That's what those parameters. Now port. Bind the port, we're going to use 5,000. All network interfaces, so you use a bind. And you want to do all network interfaces for port 5,000. And then you listen 5. Max the number of acute connections waiting to be accepted. So you listen for 5. 5 connections. Up to 5. Okay, and here's accept. So accept the client connection. Okay. Receive data from the client. Here's receive, and there's the buffer size is 1024 bytes, right? Decode bytes to strings. So then we decode it's in UTF minus 8, and you decode it. You need to decode the message. Response message received. Okay, so you get the idea. If I think it's good that if you to go in, use an LLM and ask it to explain a simple Python scripts for sockets programming, it'd be much better than what we have in this lecture. Okay, you'll learn so much more. I wonder if you could even, I know some of the stuff that lets me run it. Now, this is interesting. I noticed lately. Okay, I don't know there. I'd have to fool around with this more. I noticed lately I didn't see that in the previous version of ChatGPT. It's actually letting you run it. Okay, it lets you run the Python, which be honest with you, I have security nightmares about that for ChatGPT. I just got to say, if I bed malicious stuff inside of it to, let's say, to enumerate their servers, what's going on behind the scenes with this stuff, I wonder if I could do that. I'm not going to try it now. But anyway, so use this as a tool to learn. I make sure you get good at using ChatGPT or Claude, whichever one you do, going forward in your college career and probably for the rest of your life. I know me personally, it has, it's amazing how much it has become embedded in my life of using LLMs in just a very short period, within maybe 2 years of how much I use an LLM. And it helps me writing. I'm also lecturing at the C programming class, and I'm developing actually my assignments. It helps me develop the assignments for the class and really cool ones that I would have never been able to do on my own. And then even I also lectured a malware analysis class, and right now we're going over supply chain attacks with through Java scripts, and we're using the LLM to detect when we have a malicious JavaScript, and it's absolutely amazing. And I know there are a lot of startup companies for SOCs, security operation centers, that are embedding these LLMs into pretty much everything you could imagine. It's absolutely amazing. And also non-cybersecurity related applications. I interviewed with a company called Abridge, which is taking the conversations the doctors have with their patients and saving them and then summarizing and telling you the most important parts of the conversations through LM to save the doctors a lot of time. So it's amazing what you could think of with this LM. So I can't tell you enough. It's here. It's here now. You've got to understand it and be able to use it, right? Of course, listen to your professors. If they tell you they don't want you to use it, then don't use it. But I will encourage my students to use it in every class I teach. Okay, so cybersecurity, that's my area. Forms of malware, okay? Viruses, worms, Trojan horse, spyware, all kinds of malware, okay? If you're interested in malware, if you get further along in your career, do not hesitate to take my course. You'll love it. My malware analysis course. I go to the nth degree to analyze current malware issues, okay? There's the knowledge service attacks, right? Spam, that's really bad. Spam, right? They use it for spam. Protection and cures. Firewall, spam filters, proxy servers, antivirus servers. Now, cryptography. So we're talking about this. So that's encryption, cryptography. And so HTTPS, I've been talking about this. Only use HTTPS, not HTTP. Public key encryption is asymmetric. There's a public key used to encrypt the message, and then there's a private key used to decrypt the message. Okay. So, and certificate authorities trusted to maintain a list. They're trusted to maintain lists of public keys. All right. Provide certificates of compliance containing they contain a party's name and its public key. Here's an example of public key encryption. Now there'll be a homework question on this. Alice holds the public key, encrypts the message. Alice holds encrypted message with a public key. There's an encrypted message sent to Bob. Carol holds the public key. She sends an encrypted message to Bob. Bob holds the private key. Both and Alice can send encrypted messages to Bob, and Bob can decrypt them. Alice holds the public key. Carol holds the public key. Carol cannot, she only has the public key. She cannot intercept the encrypted message from Alice, okay? Maybe she's a jealous girlfriend. I don't know. Then she's thinking that she wants to see what's Alice is sending to Bob. And so, but she can't do that. Legal approaches to network security, computers, cybersecurity law is so fascinating. I must be honest with you. I find it so fascinating. If I wasn't into malware analysis, my second choice would be cybersecurity law. I thought about going back to school and get my law degree for cybersecurity law, but I don't know. I got enough to do to lecture here and work a job during the day. I don't really have the time. Too tired. Okay, so there's the Computer Fraud and Abuse Act, the Electronic Communication Act, there's the Patriot Act, there's a bunch of acts, Communication Assistance for Law Enforcement Act, Anti-Cyber Squatting Consumer Protection Act. Now, if you want to know more about these acts, I'm not going to cover them here. You could simply use ChatGPT and ask it, please, ask it, can you tell me more about the Computer Fraud Act? For example, like this. Right, so we know this act. Let's go here. Here's how I would use it. Right? And you put this in. I hate to say this, I could literally stay up all day and all night just with ChatGPT asking it about to learn about stuff. It's absolutely amazing. Okay, the Computer Fraud Act is a U.S. federal law enacted in 1986. Okay, and it was originally designed to address early concerns about computer hacking. A key concept is what is known as the protected computer. The term very broad includes not only government and financial institutions, but also essentially any computer connected to the internet. The CFA is both a criminal and a civil state. So when someone gets caught with malware, they get hit with this. Over time, the CFA has been controversial because it's broad language. It's very broad, right in 86. As you could see, it's an act in 86. And here's a very interesting thing about cybersecurity's laws. A lot of them are maybe a little antiquated to today's environment that you have to interpret what was meant by the law. We actually probably need better laws in these type of acts. It remains one of the most important cybersecurity laws in the United States. So anyway, so you get the idea. This is a great way to learn about those laws, right? You can go and read about. I don't think you're going to be tested. If you're tested on 'em, use ChatGPT, an LLM to know about it. So I want to see. I think that's is that it for my lecture? Okay. I think that's it. And here we are with the copyright. So that's it for the lecture. Okay. So hopefully you enjoyed that. You found it interesting. You may have areas that you have more questions are and that you want to learn about. Like I said, there might be additional courses in this course is like a summary of other courses. Okay, so I don't know. I would assume that the University of Arizona probably has a networking course. So if you like networking, take the networking course to learn more about this in detail. So what I want to do is I want to go over the homework now because I always do this to make sure. What's a protocol? You can answer these. If you use ChatGPT, just provide me the prompt that you use. That's all. Identify three protocols. Okay. Describe the steps followed on my machine to transmit a message in network using CSMA CD protocol. Now, we didn't even cover that in the lecture. Okay. I'm glad we didn't because that's so boring. It's about an old network architecture. So here's how I would use ChatGPT. I'm really fat fingered. I fat fingered it. Let me put it here. It's in an old IBM. Let's see what this thing comes back with. Of course, it's in your book also, chapter 4. Okay, listen, transmit a file, detect collisions. Okay. So it's describing the protocol and how it works, how it's avoiding collisions, right? It's all about collisions. This is all about IBM protocol. Right. Carry sense multiple access with collision detection is a media access MAC method, not okay, it's not IBM. Okay. Where IBM fits a star, I thought it was IBM actually promoted to competing link called Token Ring. Okay, that's what I was talking about, Token Ring. Okay, so forget about the OIBM. I was thinking about Token Ring. I'm glad this we didn't switches. Okay, so here they're talking about modern Ethernet uses switches instead of hubs. Switches eliminate collisions. See, that's why switch is good because they're going to eliminate collisions, like I said. So it's not IBM protocol. Okay, so you get the idea. So when you do the homework, you can use ChatGPT or use the book, Google it, whatever. But just provide me the prompt that you use, okay? Okay, here's an interesting. Using a 30-put address was originally thought to provide ample room for expansion, but that conjecture is not proving to be accurate. IPv6 uses 128 bits. Well, that proved to be adequate. Do you think so? I'll be honest with most. I think it's unforeseeable that it wouldn't be, but maybe somebody will have a good reason why it's not. Maybe because of space exploration. I don't know. Maybe that has something to do with it. I'm not sure. Or maybe quantum computing. I don't know. I don't know. But I will accept, well, if you come up with a really good reason to why it's not, boy, you might get even extra points for that. I think it is. Most everyone says it is, but if you come up with a reason why it's not, boy, that'd be a good one. If you can theorize, it'd be more theoretical, right? If a computer's address is Batman and Cave, what might you conjecture about the structure of the main contain the machine? Okay. So you can, we covered that. Modify so that the word rover is linked in the document whose URL is. Okay, so you could do that. Suppose you want to establish a fire. This is an interesting one. Suppose you want to establish a firewall to filter out email messages containing certain terms and phrases. Would this firewall be placed at your domain's gateway or your domain's mail service? So really to answer this question, what does a gateway do? Should it be placed at your domain gateway or should it be at the domain mail server? Most students get this right. A very small percentage get it wrong. Okay, and summarize the principles of public key encryption. We covered it in the lecture. I'm not looking for a six-paragraph explanation of public key encryption. A paragraph or two will do just fine. Just very basic of how it works, right? Maybe even a paragraph would be fine. That's all I'm looking for there. So that's the homework. This is our last homework. Yay, right? We made it this far. So, and then the next content is the final. Uh, I'll go real quick now and I'll go over it again in 2 weeks. You have two attempts at the final exam. The second attempt will only cover questions you got incorrect the first time. I think there's a time limit on the exam on the exam. It's due by December 14th. Try to get that done by then because I have to hand in the grades. Is that true? December 14th. I hope I have that right. No, it's not December 14th. That's not right because I'm not sure. I'm gonna have to. I'll update that later, but you can look yourself on when the semester ends. So it shouldn't take you that long to do. Uh, Everyone has been doing tremendous on the quizzes, so it's just questions from the quizzes again combined into this final. So I anticipate very high grades, and everybody has been doing so well in this course. It has just been just magnifique. Okay, so that's all I have for tonight. Does anybody have any questions before I say goodnight?
Uh, Professor Charles, our last week of final exam is on week 16 and it's end on the May 15.
Okay, so May 15th is the end of your semester.
Yeah, the final exam week.
So that starts your exam week, May 15th, or that ends it?
It end at May 15.
Okay, so in 2 weeks, so the 27th. So really, I want to see one thing. I uh
Let me,
I think I had the final set that you can go in there now if you really wanted to take it, right? Starts April 27th. Well, let's do this.
and the grades should be out by um,
All right.
wait, let me check. May 19. I have to put the grades in our system.
By May 19th.
Yeah.
Okay. So what I'm doing here is uh I do think this homework was pretty simple. I think most students will have it done in a week. I'm going to open up the final now. I started for today. So you have extra if folks want to flow right into the final. Let's see this. Let's see. Okay, I think you could take the final now if you wanted to. Yeah, so it looks like you could take the final. So I would recommend do the last homework the following week. Don't even wait for my lecture. If you've caught up on everything, take the final, get it over with. I'm sure you're going to do great. Just make sure we have it done by when the dates are due. I need at least a couple of days once the final's done to tabulate the final grades because I have to go through some of the assignments that people were late with still. And I'm trying to catch up on that. So Rafi, let me know. Do me a favor. Send me an email with that date of when you have to submit the grades,
Okay.
so I can remember that. And
Yeah.
I'll make sure I'll adjust the date on this. I'll put a comment in here telling please be done a few days before this date. I just need a couple of days uh, to submit the grades. Okay? Does that sound
Okay.
good?
Yes, thank you very much.
Oh, you're welcome. Thank you. I really enjoy working with you as a teaching assistant. Any other questions? If not, I'm going to end my share. And before I end the lecture, I would like to say thank you very much for listening to me every other week. I have a lot of respect for the remote students. Um, I know it's a lot of work. Everyone's done fantastic, and I want to wish everyone lots of luck in their career. And don't be afraid, hesitate to hit me up and maybe even look for my future classes and sign up for my classes. Okay? Take care, everyone.
Thank you very much.
Okay, take care.